The first sum is so find I using superposition theorem. Second, find an equivalent circuit across AB using Thevenin's theorem. Then find current through 25K. Third one is find equivalent resistance across AB by using Norton's theorem and find current through 25K. That is the assignment sum. Is it assignment for me? Okay. Okay. So superposition theorem means what is the meaning? We have to consider one source at a time. We have to consider one source at a time. So here, how many sources are there? Three sources are there. That's why we have to find three currents through 25K. We have to find three currents through 25K. The three currents has to be added algebraically. You will get the total current. That is superposition theorem. If it is a linear network, each source can be acted separately. The sum of all currents equal to, if all together acts, means that is the total current. That is superposition theorem. So for that, we have to find current through the 25K. We are going to consider the 12 volt first. So if you consider the 12 volt first, the circuit can be redrawn like this, 20K. If it is voltage source, we have to short circuit it. If it is current source, we have to open it. So we have to open this current source. We have to open that current source. Then we have to find that current through the 25K. If you open this 9 milliamps also, 3 milliampere and 9 milliampere are opened. Now we have to find the current through 25K. So current direction will be this way, opposite to the, this is the given direction, that is positive. But actual direction is this way. This is actual because this is the positive terminal. That's why this is actual direction. That's why current answer must be in negative. We have to find I dash. Now current through this is I dash. Why I dash? I single dash. Because we are considered the first source. That's why I single dash. What is the current through this? Very simple. 12 volt. Current through this is 12 volt divided by sum of all these resistances. Therefore, I dash equal to minus. Why minus? Actual direction is opposite to assumed given direction. That's why minus. What is the voltage? 12 volt divided by total resistance 20 plus 25, 60K. 12 by 60K equal to how much? 0.2 milliamps minus 0.2 milliampere. One result we got. Now let us consider 3 milliampere. If you consider that 3 milliampere, then the circuit becomes 20K. Voltage source means we have to short circuit. Voltage source means we have to short circuit. Current source means we have to open. So we are going to consider that 3 milliampere. We have to consider that 15K, 25K. We have opened this 9 milliampere. That's why that is not in the picture. This is also very simple. We have to find current through 25 ohm. We can draw one more circuit. Actually, that is not required, but anyhow, let us draw. Let us draw 20K, 3 milliampere, and these two are in series. That's why 40K. Am I correct or not? So we have to find through 40K what is the current we have to find. So total current is 3 milliampere. That's why I double dash equal to I 40K equal to 3 milliampere multiplied by other branch resistance 20K divided by total resistance 60K equal to how much? 2 by 6 or 1 by 3 equal to 1 milliampere. Now, what is the direction of current? What is the direction of current? Direction is this way. This is actual. Assumed is this is as given. Given direction is given direction. So it is opposite. That's why we have to consider that minus sign. So minus, that is equal to minus 1 milliampere. That is second current we got. Now itself we can write this. Anyhow, we'll go one more step. Here 40K through that 40K 1 milliampere. Through 40K 1 milliampere. That is in series. Series means currents are equal. Series means currents are equal. That's why 1 milliampere. But opposite direction, that's why minus 1 milliampere. That is I double dash. Why double dash? We considered second source. Now we have to consider the third source. What is the third source? 9 milliampere. So 12 volt is short circuited. 20K, 30 milliamp. This is removed, opened, and 15K, then 25K. (9 milliampere). Here, the actual direction and the given direction are same. This 15 and 20 are in series. That's why we can draw one more circuit. 20 plus 15, 35K. And here 25K. 9 milliampere. So we have to find current through this 25K. That's why other branch resistance divided by sum of resistances. Therefore, I triple dash equal to 9 multiplied by 9 milliampere multiplied by other branch resistance divided by sum of resistances. 25 plus 35. How much? 25 plus 35, 5 point. 60. Okay. K. 25K and 35K. That is equal to how much? 5.25 milliampere. So now to find the total current, we have to add all together. I equal to I dash plus I double dash plus I triple dash equal to minus 0.2 minus 1 minus 5.25. That is equal to plus 4.05 milliampere. So this is by superposition theorem. We got this by superposition theorem. Now let us solve the same by Thevenin's theorem.